NFPA 780, Standard for the Installation of Lightning Protection Systems, Section 1.2.1 states that a cone of protection is the volume of space within which a structure and its contents are protected from a lightning strike. Section 4.3.2.2 states that the cone of protection for a single vertical air terminal shall be assumed to extend out from the highest point of the roof to the ground at an angle from the vertical of 45 degrees. The International Code Council (IC) Code for Lightning Safety, Section 402.21 states that the cone of protection for an air terminal shall extend a distance equal to the height of the protected structure, or 10 feet, approximately 3 meters, whichever is less, in all directions from the protected point. Based on these standards and codes, it can be concluded: firstly, the cone of protection extends in all directions from the highest point of the protected structure, and secondly, a building falling outside the cone of protection of a lightning protection system is not more prone to being struck by lightning due to the installation of the lightning protection system. It's important to consider that the presence of taller structures nearby can affect the cone of protection and extend it. Grounding and bonding are crucial for the proper functioning of a lightning protection system. If the grounding system is not properly installed or maintained, the system may not be effective. Regular inspections and maintenance of lightning protection systems are essential to ensure their continued effectiveness. Let's delve deeper into the specifics of lightning protection systems and the concept of the cone of protection. A lightning protection system, or LPS, is designed to protect a structure from damage due to lightning strikes. It provides a path for the electrical current to follow, safely guiding it to ground. The cone of protection is a crucial aspect of LPS design, defining the area where the system offers protection. The size and shape of the cone of protection depend on several factors, including the height of the air terminals and the type of structure being protected. Air terminals, also known as lightning rods, are the highest points of the LPS and are designed to intercept lightning strikes. They are typically made of copper or aluminum and are strategically placed on the roof of the building. The number and placement of air terminals are determined by the size and shape of the building, as well as the level of protection required. The cone of protection is often visualized as a cone-shaped area extending downwards and outwards from the air terminal. Any object or area within this cone is considered to be protected from a direct lightning strike. The angle of the cone is typically 45 degrees, but this can vary depending on the specific standards and codes being followed. The NFPA 780 standard provides detailed guidance on the design and installation of lightning protection systems. It covers various aspects, including air terminal placement, grounding requirements, and bonding of metallic objects. The standard also includes information on the cone of protection and how to determine the appropriate level of protection for a given structure. The ICC Code for Lightning Safety is another important resource for lightning protection design. It provides similar guidance to NFPA 780 but may have some variations in specific requirements. When designing a lightning protection system, it's important to consider the specific requirements of both NFPA 780 and the ICC Code, as well as any local building codes that may apply. Grounding is a critical component of a lightning protection system. It provides a low-resistance path for the lightning current to flow to ground, minimizing the risk of damage to the structure and its contents. The grounding system typically consists of ground rods or ground plates that are buried in the earth and connected to the air terminals and other components of the LPS. The resistance of the grounding system should be as low as possible, ideally less than 25 ohms. Bonding is another important aspect of lightning protection. It involves connecting metallic objects within the structure to the grounding system to prevent dangerous voltage differences from developing during a lightning strike. This includes bonding metal pipes, ducts, and other metallic components to the grounding system. Proper bonding helps to equalize the voltage potential throughout the structure, reducing the risk of electrical shock and fire. Regular inspections and maintenance are essential for ensuring the continued effectiveness of a lightning protection system. The LPS should be inspected at least annually and after any significant weather events, such as thunderstorms or high winds. During the inspection, the air terminals, grounding system, and bonding connections should be checked for damage or corrosion. Any damaged or corroded component should be repaired or replaced immediately. In addition to regular inspections, it is also important to perform periodic testing of the grounding system to ensure that it is still providing a low resistance path to ground. This can be done using a ground resistance meter. If the resistance is found to be too high, the grounding system should be repaired or upgraded. The presence of nearby structures can affect the cone of protection of a lightning protection system. Taller structures can intercept lightning strikes that would otherwise have struck the protected structure. This can effectively extend the cone of protection, providing additional protection to the surrounding area. However, it's important to note that the presence of nearby structures does not necessarily eliminate the need for a lightning protection system on the protected structure. The specific requirements for lightning protection will depend on the size and shape of the structure, as well as the level of protection required. The distance between structures is a key factor in determining whether one structure's lightning protection system offers any protection to another. If the structures are close enough, the cone of protection from one structure may extend to cover the other structure, providing some level of protection. However, if the structures are too far apart, the cone of protection will not extend far enough to offer any significant protection. The concept of the cone of protection is based on the principle that lightning tends to strike the highest point in an area. By installing air terminals on the roof of a building, the lightning protection system provides a preferred path for the lightning current to follow, safely guiding it to ground. The cone of protection represents the area where the air terminals are most likely to intercept a lightning strike, protecting the structure and its contents. It's important to understand that the cone of protection is not a perfect shield. There is still a small risk of lightning striking outside the cone, particularly in areas with complex terrain or unusual weather patterns. However, a properly designed and installed lightning protection system significantly reduces the risk of damage from lightning strikes. The effectiveness of a lightning protection system depends on several factors, including the quality of the components, the skill of the installer, and the regular maintenance of the system. It's important to choose a qualified lightning protection contractor who has experience in designing and installing LPS systems. The contractor should be familiar with the latest standards and codes and should use high-quality components that are designed to withstand the harsh conditions of a lightning strike. In addition to protecting structures, lightning protection systems can also be used to protect outdoor areas, such as parks and golf courses. In these cases, air terminals are typically mounted on poles or trees, creating a cone of protection over the area. The grounding system is typically more extensive in these applications, as the area being protected is larger and more exposed. Lightning protection systems are an important investment for any structure that is vulnerable to lightning strikes. By providing a safe path for the lightning current to follow, an LPS can significantly reduce the risk of damage to the structure and its contents. It can also help to protect people from electrical shock and fire. When considering a lightning protection system, it's important to consult with a qualified lightning protection contractor to determine the appropriate level of protection for the specific structure. The contractor will assess the size and shape of the structure, as well as the surrounding environment, and will recommend a system that meets the specific needs of the property. In summary, a lightning protection system is a crucial safety measure for any structure that is susceptible to lightning strikes. The cone of protection is a key concept in LPS design, defining the area where the system offers protection. By understanding the principles of lightning protection and the cone of protection, property owners can make informed decisions about protecting their structures from the dangers of lightning. Furthermore, ensuring proper grounding with a resistance of 25 ohms or less is paramount for effective lightning protection. And while taller structures might seem to offer extended protection, a dedicated LPS remains essential.